Immortality is tantalizing close.
And you think it's possible within the laws of physics and biology?
In fact, we know that there's a clock in our body called the telomeres that tracks how long we're going to live. And there's something called telomerase which stops the clock, which means that we can live forever. That's the good news. But the bad news was we found out that cancer also uses telomeres and telomerase to live forever. And so the question is, can we apply that to humans without wakening up the cancers? But this is not science fiction. This is the future.
And for 71 years, you've been studying physics and how science will shape human destiny. So how is life likely to be different in the future?
Well, decade by decade, we see the enormous progress that we humans have made. For example, we'll probably be on the moon, maybe into Mars, and also artificial intelligence will help us to cure cancer and many diseases. However, for the first time in human history, we have the potential of destroying ourselves with designer germs, nuclear weapons, perhaps artificial intelligence. Like this is a quantum computer. This is so powerful that even the CIA is worried about the fact that this could break into any known computer,
Including banks, even Bitcoin.
That's right. So capitalism would vanish, society would come to a halt.
And what about humanoid robots?
I would look seriously at the possibility of merging with them so that we don't have a civil war. Realize that we're at the edge of a knife. You tilt it the wrong way and there's world war. You tilt it the other way and there's food and luxury for everyone. And it's up to us to decide which way the knife will go.
Dr. Michio Kaku, I've waited a long time to ask someone these questions. Where do you believe we came from? Do you think it's plausible that in fact we are living in a simulation? And then, is there any evidence when we look out at the stars that there is non-human life out there?
Okay, first of all,
this is super interesting to me. My team give me this report to show me how many of you that watch this show subscribe. And some of you have told us, according to this, that you are unsubscribed from the channel randomly. So favor to ask all of you, please could you check right now if you've hit the subscribe button, if you are a regular viewer of the show and you like what we do here. We're approaching quite a significant landmark on this show in terms of a subscriber number. So if there was one simple free thing that you could do to help us, my team, everyone here, to keep this show free, to keep it improving year over year and week over week, it is just to hit that subscribe button and to double check if you've hit it. Only thing I'll ever ask of you. Do we have a deal? If you do it, I'll tell you what I'll do. I'll make sure every single week, every single month, we fight harder and harder and harder and harder to bring you the guests and conversations that you want to hear. I've stayed true to that promise since the very beginning of the Diary of a CEO, and I will not let you down. Please help us. Really appreciate it. Let's get on with the show. Dr. Michio Kaku.
that's right.
For anyone that isn't aware of you and your work, and they're wondering whether they should listen to what you have to say today because they don't know your work and they've not gone through the books and the interviews that you've done, how would you describe your experience?
I work in something called string theory, which we think is the theory that eluded Einstein for the last 30 years of his life. The theory of everything. The theory that explains the Big Bang, the formation of stars, galaxy, formation of the Earth, life. I'm a physicist working in the theory of everything.
What is the theory of everything?
An equation perhaps no more than 1 inch long that will allow us to, quote, read the mind of God. These are Einstein's words. The theory of the Big Bang, the theory of creation itself, the theory of everything.
I want to explain this in terms that even the most sort of novice viewer could understand. The theory of everything is an equation that explains
everything.
Physics.
No. From physics comes chemistry, comes biology, and from that comes our universe.
Is it things like gravity and
That's
space
right.
and time?
Gravity, light, force. There are 4 fundamental forces of the universe. There's the gravitational force, which keeps us here, the electromagnetic force, which lights up our world, and the 2 nuclear forces. We want a theory that explains all 4.
You know, in your interviews and they read your books, what do you think is the fundamental question that they're typically seeking to answer?
What does it mean?
For
the physics of the future. That is, we physicists create the future. We're the ones who understand what is possible, what is not possible, and what is plausible. How does that affect the average person?
And there's an element of all of us that's just trying to figure out how we got here. We're up in the universe.
Yeah, if for philosophical or religious, they want to know, what does it all mean? I mean, where'd they come from? Where's the universe going? They want to know the answer to the big questions, the question of meaning. And that's what we physicists do.
And they want to know if we're alone in the universe.
Oh, yeah, that too. What we do is look for extraterrestrial intelligence.
You've been doing this for many, many decades now. You've been studying the nature of the universe and physics. Is there a fundamental misunderstanding that you're aware of that the average person still believes?
Yeah, people think physics is for eggheads, that it's just doing equations on a blackboard and totally divorced from the average person. They don't realize that everything about their life, about electricity, about magnetism, about the nuclear force, about industry, everything comes from physics. But the average person thinks that physics is for eggheads. It's for equations you put on a blackboard in a cartoon. Nope, it's everywhere.
In the last couple of weeks, you've been asked to do lots of interviews because Trump has released the UFO files.
That's right.
Before we get into lots of other subjects and physics generally, probably start by just tackling this question head on. Do you think that we are alone in the universe?
No, we're not alone because the galaxy has 100 billion stars, of which maybe 10% have planets that are Earth-like or are similar to Earth. But the question is, can they visit us? A Saturn V rocket would take 70,000 years just to reach the nearest star. Hop, skip, and a jump, 70,000 years. So a civilization that could reach the Earth would be hundreds, thousands of years advanced than us. So I'm a physicist. We look at that. Space warps. Is it possible that a flying saucer race could create a space warp so they could visit us?
Space warp?
Bending space.
Is that possible?
Well, gravity bends space all the time. The question is, can you bend space enough so that you can go faster than the speed of light so you can visit the nearest star? That's a question mark. We physicists look at that, but we have no definite answer. But it's possible.
So what these people say that, I had recently where two people explained to me that there's been some very unusual sightings of UAPs.
Right.
And this is evidence to say that aliens exist. Do you think sightings are actually extraterrestrial life, or do you think it's just people hallucinating and seeing, light orbs and misunderstanding what they're looking at?
Well, there are three types of observations. The close encounters of the first kind is when you see something in the sky, first kind. Close encounters of the second kind is when you have something tangible, an engine, a body, a wreckage of a UAP. That's second kind. Close encounters of the third kind is when you actually encounter them and shake their hand. Now, where are we? We're at close encounters of the first kind, where we see things floating in the sky, but we don't know what they are. We don't have anything tangible. Now, in science fiction, we've captured the flying saucer. We have the aliens in a cage, so on and so forth. That's the movies. We have yet to see an alien in a laboratory. We have yet to see an alien ship. In other words, people say, I saw something. Now, what does that mean? I'm a physicist. We go and we have no observations to verify what you saw. Except, of course, sensationalists who say, I've seen the bodies. Okay, show us.
So I conclude that you don't believe alien life has arrived here on Earth before.
No, I'm open to possibility. 95% of the sightings we can using the laws of physics. 5% are either optical illusions or they are evidence of visitation. You can't rule it out. So I'm open to the idea that maybe they're here. Now, President Trump has released the first mountain load of 160 counters of alien technology, we think. But we haven't yet seen a close encounter of the second kind. When that happens, that's a game changer. When we have a piece of faux hardware, that would the wall right there.
There's a narrative that the US government, or generally governments around the world, wouldn't want the people to know about aliens because they're not ready for it. Do you buy that?
That's the traditional excuse for not revealing these things. But the other excuse is that it's a cover. It's the stealth bomber. It's a cover for the fact that the military does experiment with aerodynamically novel forms of transport. And so those are the reasons why the military keeps it a secret and actually lies about these things. But now it's leaking out. Congress, the President of the United States, they're demanding these sightings to be classified. The physicists now are analyzing them to see whether or not they're really real or not.
Is there any evidence when we look out at the stars that there is non-human life out there Is there anything that you've seen when you look at other planets and how they're operating that might suggest there's a different type of life there?
Oh, yeah, but there's no tangible word yet, though.
Give me one example.
For example, take a look at Alpha Centauri, the closest star system to the planet Earth, right?
How far away is that?
4.5 light years. And if you take a look at the Alpha Centauri system, the closest system to the Earth, you have red stars that could have life on them. We're not sure. They're not super hot, super large, in which case it would be very difficult to get life forms off the ground. But the point I'm raising is that the Milky Way galaxy, our backyard, has 100 billion stars. And the probability of life existing among those stars is almost 100%. The question is, can they reach us? That means, is it possible to create a space warp such that you can break the light barrier so that you can travel across the galaxy and visit the Earth?
And did you say that was theoretically possible?
It's theoretically possible, yeah. But of course, you need fantastic amounts of energy. But the laws of physics do allow for the possibility of space warps. I mean, you've seen space warps, but where does Star Trek get the word space warps? It comes from physics.
I also heard you telling, I think it was Joe, telling a story of one particular star that reduces in its intensity by 20%.
Yeah, there is a star that oscillates.
What does that mean?
So it drops by about 20%.
So it's reducing its light 20%.
That's right.
How often?
You don't have to wait for centuries. It's within a matter of months to years.
A star that frequently reduces its light output 20%.
Yeah, which is very unusual. It's the only source we've seen so far.
One of the theories, I think, when you first talked about this, was that a civilization might have built something around that star.
Oh, yeah, that's one of several theories. A civilization that advanced would have tremendous energy needs. Mm-hmm. And the easiest way to get energy is by encircling the mother star with an envelope. And the envelope then would absorb most of the energy. In fact, that was an episode of Star Trek. They meet a star that is totally enveloped by a metal shell. The aliens left it centuries ago. But, it can't be ruled out.
Theory goes that an advanced civilization will surround it with like a metal sphere to capture energy.
Yeah.
And that would explain why the 20% reduction in the light output?
No, they think that it's probably an orbiting globe that equals the star. Rather than envelops the mother star, it simply goes around the mother star and eclipses it. That's the theory.
So it'd be like a big ball that circles the star, extracting it.
And that would cause a dip in the intensity of light.
As far as we see it. Right. Because this big ball is sometimes moving in front of it.
That's right. Exactly.
Why couldn't it just be a planet?
Planets are not that big. Planets are about 1%. Like Jupiter is about 1% to the sun. So the sunlight would drop by about 1 or 2% if Jupiter goes in front of our sun.
Oh, I've got you.
So this is much bigger. It's huge.
You've written a lot about the universe and physics and everything in between. I've waited a long time to ask someone this question, and it's a very broad question. And the question is, where do you believe that we came from? Where do you believe that life came from? Where do you believe this came from?
Well, the universe came from the Big Bang. The question is, where did the Big Bang come from, right?
Okay, so what is the Big Bang?
A Big Bang, a cosmic explosion that took place around 14 or so billion years ago that created the expanding universe.
How do we know that happened?
Because we have evidence of this expansion that took place, 14 or so billion years ago. We see this moving away from us. So think of a big balloon with points of light on and the balloon is expanding and the stars are moving away from each other. Mm-hmm. That's what we see today. Not moving toward each other. All the stars are moving away from each other like the sphere is expanding. And so we believe in the Big Bang theory, and we believe that it's expanding rather than contracting.
Expanding into what?
Hyperspace.
What's that?
Well, we live in a 4-dimensional universe, 3 dimensions of space, 1 dimension of time. We live in a 4-dimensional universe. But in string theory, we believe that there are 11 dimensions altogether.
String theory is something that you came up with?
I came up with string field theory, which is one of the branches of string theory, right?
And what is string theory?
String theory says that what is a proton, what is an electron? They're nothing but vibrations of a string. So from a distance, this looks like a point particle. From a distance, this is an electron. But if you could magnify that, we find out it's not really a point at all. It's really a vibrating string. And each vibration corresponds to a note. So this would be a proton. This would be an electron. This would be a neutron. This would be a neutrino. That's why we have so many subatomic particles.
Okay, so to simplify this in a way that you're saying that at the very base layer, particles are the same, but they're just strings that are basically vibrating differently.
That's right.
And that would be the sort of foundational matter of everything.
That's right. Everything, basically a vibrating string. So when the string vibrates in this direction, we call it an electron. If it vibrates in this way, we call it a proton. So why do we have so many subatomic particles? How many of them are there? Hundreds. We've seen hundreds of subatomic particles. And how could Mother Nature be so malicious to create a universe at the fundamental level based on hundreds of different kinds of strings vibrating in different directions? Well, it's really just one string. One string that can vibrate in different modes, each called a particle.
Why does it need to be a string?
We don't know why things are. I'm a physicist. We just try to figure out the way they are. But it will explain why there's so many particles. We used to think there was an electron, a proton, and a neutron, and that's it. That's it, period. Nope. We've seen pi mesons, we've particles, omega particles, hundreds of subatomic particles. Why do we build atom smashers? Outside Chicago, outside Geneva, huge, gigantic atom smashers smashing atoms apart. Why? Because then from the debris, we begin to figure out these vibrations are particles. We can categorize them. We can give them names. And that gives us, a theory of everything. So we have what is called the Standard Model, which explains all the subatomic particles other than gravity. And we create these particles with their atom smashers.
Which is big machines where they fire atoms at each other in Geneva and so on around the world.
That's right.
To figure out.
That's a Large Hadron Collider, right. But now we realize that there's an octave. There's another layer even beyond what we see with the Large Hadron Collider, dark matter. Dark matter is invisible matter that surrounds the Milky Way, and we don't know what it is. There's a Nobel Prize waiting for somebody who could figure out what dark matter is. It's invisible matter. Invisible matter that surrounds the entire Milky Way galaxy. We cannot yet prove that it's nothing but the next octave.
What do you mean by octave?
Vibration. In other words, this would be the lowest vibration, which corresponds to... There are other vibrations much bigger, and they would correspond to a higher octave.
How do we know it's there if it's invisible?
Well, this is a guess. But it turns out that when you do the math, and you look at the vibration of a string, and you look at the higher vibrations, some of them are invisible. In other words, they don't interact with light. Now, we know that this interacts with light, therefore we can see it.
The table.
But these are the lowest vibrations. Some of the higher vibrations are invisible. And so we think that's what dark matter is.
I guess this all comes back to the question, we were talking about the Big Bang. You know, scientists tend to agree that there was some kind of big, you look at the universe, it's expanding outwards. So one would, if you rewind time, at some point, there was a central point where an explosion occurred if you reverse time. It begs the question, what caused the Big Bang?
Well, we don't know. There are theories. String theory is a theory even before the Big Bang. It's a theory of everything. The Big Bang, in some sense, is a misnomer because it disguises the fact that we're ignorant. We're ignorant of what caused the thing to bang. String theory, there was no bang. It did collapse, if you go backwards in time. It did collapse with a very small thing and then came out again. It bounced.
Oh, okay.
So we think that there could be a bubble bath of universes.
What do you mean bubble bath of universes?
Our universe is a bubble of some sort, and the bubble is expanding, and that's called the Big Bang Theory, which fits all the data. But we think there are other bubbles out there. In other words, string theory says that we live not just in a 4-dimensional world, but in a 11-dimensional world. These other dimensions we cannot see. But we think that the universe coexists with other universes. There's a bubble bath. Think of bubbles, soap bubbles floating in the vacuum.
What about marbles? So when you're talking about bubbles, you mean like kind of like this?
Right. Okay. Give me the big one. All right. This is the sun.
Yeah.
And these are planets, asteroids, whatever, and they're going around the sun. Mm-hmm. Why are they going around the sun like that? Because this exerts gravitational force. It's pulling these things toward the sun. The Earth is just one. Asteroids are none of the other. Saturn, Jupiter, they're nothing but planets going around the mother star. And so then the next question is why? Why is it that planets are going around the sun? It's because the sun is warping the space around it. It's creating a shallow depression. Space is not flat. This is Einstein's achievement. You go in this direction, seems flat. You go in this direction, everything seems to be flat. For example, is round, but it looks flat, but it's not. The universe looks flat, but it's not. It's curved. And that's why planets go around the mother star, because gravity is a byproduct of the warping of space, and that's why we are sitting on this chair right now. Why are we here? How come we're not flying in outer space? The Earth is spinning, right? If the Earth is spinning, we should be flung out into outer space. Here.
Gravity.
But what is gravity, though? That's just a word,
Isn't
right?
it just because the mass of the Earth is so much greater than us that it pulls us in?
Okay, well, why is it pulling us in? Einstein says that the reason why the Earth is in is because the Earth warps the space around us and is pushing us into the floor. That's why the solar system works the way it does, because the sun grabs the planets and forces the planets to move in a curved line because it's curved space that is causing it to move this way.
And going back to what you were saying about the bubble bath idea.
Right. Then the question is, are there other stars? Yes. Are there other galaxies? There are billions and billions of planets out there. We think that the whole shebang is curved. We're nothing but inhabitants on the skin of this gigantic bubble. Now we're saying that maybe there are other bubbles out there. A multiverse of universes, parallel universes. In fact, word multiverse has gotten into the books now referred to the multiverse, Spider-Man and things like that. So it's even part of the vernacular, the common language of the average person, that we believe in parallel universes. So yeah, these universes come from physics.
And the other thing that comes from physics is black holes.
That's right. If this star becomes so massive that its gravity is so great that it pulls the entire shebang in like this, then that would be a black hole. And we now believe that at the center of almost every galaxy we see, and there are trillions of galaxies, we think that at the center of these galaxies, there's a black hole.
Even our galaxy, the Milky Way.
Even our galaxy, right? If you look in the direction of Sagittarius, the constellation black hole there. So tonight, go outside, look for the constellation Sagittarius, and there's a black hole at the center of our own backyard that holds the Milky Way galaxy together.
So how did it get there?
Well, we think that it's a remnant of the Big Bang, that when the Big Bang exploded, clusters of matter begin to contract other clusters of matter, and this is where the galaxies and the planets come from. The condensation of the matter ejected out of the Big Bang gives you the galaxies, the solar systems, and the planets.
So if I use this as an example, there was the Big Bang and all the pieces flew everywhere. And then because of gravity, the pieces came together and they got so big, so much mass that they collapsed inwards.
We're not sure about exactly which came first, the galaxy or the black hole came first. But let's assume for the moment that the black hole came first. Gas concentrated into a small area called the black hole, and then it drew all the other stars and galaxy around it to create the Milky Way galaxy. We're not sure, but that's one possibility of where it came from. And where did that come from? That in turn came from the explosion that created the universe roughly 14 billion years ago.
Am I right in thinking black holes, they are extremely dense, like areas of matter, and if you were to go near one, everything that goes near it gets sucked in?
That's right, and you never get out again. If this is a black hole, there is a ring or a sphere surrounding it, a point of no return. You go toward the black hole and you pass this ring, and then you go into the black hole, never to be seen again. It's a point of no return.
We know that.
Well, we've never seen it happen, but we can calculate the escape velocity. In other words, if you want to leave the Earth, how fast do you have to move to leave the Earth? 7 miles per second. Our astronauts travel 7 miles per second to reach the moon. Okay, that's called escape velocity. So every gravitating piece of matter has an escape velocity. For the Earth, it's 7 miles per second. What about the escape velocity of a black hole? It's the speed of light. That's why if you fall through the event horizon of a black hole, you never come out. Because otherwise you would have to go faster than the speed of light, which is not possible. So you go in, but you never come out. That's why it's called black holes.
What's in there?
If you knew, you'd win a Nobel Prize.
This area has loads and loads of mass inside it. It's sucking things into it. So one would assume that there was a lot inside there, but it's tiny, right? Black holes are tiny?
We don't know how big they are. We think at the very center, it could be very small. We're not sure. No one's ever been there because if you go past the event horizon, you never come out again.
What do people think is inside a black hole? Because I'm thinking of it's just this area in space that looks black when you look at it, and it can suck in planets, anything.
If I were to take a guess, I would say that it's an entrance. It's a gateway, perhaps to another universe. We think, for example, if I have a warp space and you fall into warp space, if the warp space is powerful enough, it may come out again on the other side. Mm-hmm. So there may be another on the other side of a black hole. We're not sure, of course. If you want to go to Alpha Centauri with a Saturn V rocket, it would take to reach the nearest star with our most powerful rocket. Very impractical. You need a shortcut, and that's the gateway called a wormhole, which is very similar to a black hole. A little bit different, but very similar.
Have you been studying physics in the universe now?
Since I was 8 years old, I've been studying the universe.
71 years.
Yeah, when I was 8 years old, a great scientist had just died. It was in all the newspapers. And the newspapers said that he failed on his last try to create a theory of everything. So I was fascinated by this idea that this man was attempting to find the final theory.
You're talking about Einstein.
That's right. Later, I found out the man's name was Albert Einstein. And at that point, I said to myself, that's for me. That's what I want to work on. I want to be part of this great journey to complete Einstein's dream of a theory of everything. And that's what I do for a living. I work with Einstein's equations.
So for 71 years, you've been trying to understand the universe and create this theory for everything. In that time, how is your perspective on God developed?
Yes, most of my family were Buddhists coming from Japan, but my father was a Christian and put me in Sunday school. So I had the benefit of two religions as a child. Now I'm a physicist, and physicists are, quote, agnostic. They don't take a position. They simply go where the physics takes them, into areas that are distasteful, mysterious, whatever. You go where the evidence goes, and that's what I am today. In other words, we have the laws of physics. We have string theory, which takes us to the instant of the Big Bang, and even before the creation of the universe. But then the next question is, where does string theory come from? Okay? And we have to say that that's where our ignorance takes over. We simply don't know.
What about simulation theory? I think it's plausible that, in fact, we are living in a simulation.
I would say the answer is probably no.
Probably no.
That's right. Simulation theory is basically saying that the universe is a puppet show and there's a script. We're living out the script because somebody is pulling our strings. First of all, that violates quantum theory. Quantum theory believes in probabilities. Probabilities that I'm sitting here today, probabilities that maybe one day I'll go into outer space. We can calculate the probabilities of events, chemical events, with accuracy that is incredible. But simulation theory is not one of them.
The theory, which was proposed by philosopher Nick Bostrom, says that there's three possibilities logically. Either number one, that human-like civilizations always destroy themselves before they get to the point where they can do advanced hyper-realistic simulations. And if you look at things like, I know, virtual reality at the moment or video games, and you imagine them on a spectrum, if they just get 1% better a year, at some point they are indistinguishable from this reality that we're experiencing now. So Theory one, we wipe ourselves out before we get to the point where we're advanced enough in hyper-realistic simulations. Theory number two, or possibility number two, is that advanced civilizations do exist, but they have zero interest in simulating their ancestors, which would be us. Or theory number three is that we are a simulation, and civilizations do survive, and they do run millions of simulations because there would be millions of fake universes and only one can be base reality in this scenario. And the mathematical odds are incredibly high that we are currently living inside one of those simulations and not in base reality.
Well, my personal point of view is there's option 4 that you don't mention. And option 4 is that there is no simulation at all. That all this talk is nothing but fairy tales that we tell our children to amaze them about the universe. But you see, the universe is based on that uranium will fire, for example, which gives us nuclear weapons. Probability that hydrogen can fuse, and that gives us stars. So the universe is based on probabilities, not on simulations.
Do you think what we're seeing, this is a strange question to ask because, again, there's so many definitions within it, but do you think what we're seeing is real? Like, do you think this is, because people do psychedelic drugs and I hear about things like DMT, you inhale a little bit of smoke and suddenly everything is different. And you meet people talk about how they've met other types of life when they've taken an inhale of DMT. They've interacted with some type of other life form. So I guess all this is to say that if our perceived reality is that fragile, where we inhale one of smoke and suddenly we're amongst a different life form, then it makes us question whether this is real at all. And also, like, just to extend it a little bit further, if one inhalation of smoke, and I guess you could think about that as a bunch of small particles, can interrupt something in my brain that causes me to believe that I'm in a different universe, then doesn't that prove that my reality is just the projection of a very fragile small amount of particles that are right now lined up so that I see you and this?
Well, I think the answer to that is that what you consider to be reality is really a partial fiction. That your senses are limited by what your senses can retrieve from the outside world, but it's only a teeny weeny little fraction of what actually exists. Look at the electromagnetic spectrum of light, for example. You can't see all the ultraviolet radiation, the infrared, X-rays. This room is full of realities that you can't see. Most of what you see is a fragment, a teeny, weensy little fragment of reality. You can't see cosmic rays. You can't see ultraviolet radiation. So what I'm trying to tell you is that you live in an illusion. It's a good illusion for survival. But in terms of being able to see the full spectrum of reality as it exists, no, there's no way. So you think reality is everything. Nope. It's only a tiny, weensy little fragment of reality. And talking about this reality, that's a fantasy on top of a fantasy. The fantasy is that you think that what you see is real and everything. That's the first fantasy. The second fantasy is there's a fantasy within the first fantasy. So you're going layer upon layer of fantasies. Now, let me give you another example. Let's say you hear rustling in the forest. You think it's a tiger there. 9 times out of 10, there's no tiger there. But how come your senses are constantly alerting you to the tiger? And that is evolution. Evolution gives you the ability to see things that are not really there at all because it's good for survival. One time there is a tiger and it saves your butt. In other words, why are we here today? We're here today because our senses are overactive. Our senses think there's a lion, there's a tiger there, when there's no lion or tiger there at all. But it was good for our survival, okay? So our senses are only necessary for our survival. That's why we cannot see infrared, we cannot see ultraviolet, we cannot see the whole spectrum of reality, radio, everything. We can't see it all because it was not necessary for our survival.
Why does life matter in the universe? Like, what function does life have in the universe?
I think we create our own meaning individually.
But why would
I think there's no meaning for life in general, but I think each of us create our own meaning.
I was saying this because you were talking about, survival. And I was just wondering if there was some universal reason why survival is so important to the universe.
Survival in the universe, because survival writes history. If there's no survival, there's nothing to write. There's no memories. There's no stories to tell. Nothing. It's just the vacuum of space.
I was also asking that, I guess, because you were saying how we only see one version of reality. And so one would assume, therefore, that there's another version of reality that we can't even see. I mean, I've heard this before from physicists, and if you just think about different animals, the bat sees a different version to the whale.
Like sonar, for
example. Even my dog seems to see a completely different version of reality than the one I...
Smells much better than you. Olfactory nerves of a dog are infinitely better than our olfactory nerves in our nose. They have a different reality.
I guess it begs the question, what is all of this then?
You're talking about the meaning of life, for which I have no answer. Sorry about that.
I guess that was what I was asking, but that wasn't what I was intent on asking. But that's the base question, which is, what's the point?
I'm not even sure if the universe has a point. But my personal attitude is we create our own point. We create our own world and meaning within that world. It could be different from another person's meaning and understanding of the world, but it's good enough for me.
What do you think of the human sort of proclivity to imagine a God and to assign meaning and morality to that God and say, well, we do live with this kind of God-shaped hole in our lives where we don't really know where we came from, we don't know what the point is. So I understand why it's tempting to say this book that someone wrote once upon a time that says, this thing created us, and these are the rules, and this is what good is, this is what bad is, this is what we get if we follow the rules. As humans, we want that.
Yes, and I think there's a reason for that. And the answer is evolution. What holds the alpha male, the top dog? As humans became more intelligent over millions of years, humans bicker, we argue, we challenge the leader, and then tribes would fall apart because you need some glue. You need some glue to hold it together. And if everyone becomes intelligent uniformly, there's no glue anymore. Everyone knows I'm the leader, so on and so forth. So what happens is one person comes up and says, I'm stronger than you. And I talk to somebody even stronger than me, God. And if you disobey me, then God will strike you down. In other words, God is a glue. God is a glue that holds sentient beings together when there's no reason to hold them together anymore and the tribe falls apart. What holds the tribe together? God. Who is God? Well, God is not here, but the Son of God is here. And the Son of God says, you got to do this, you got to do this, you got to do this, and you got to obey me. Why? Because I'm the messenger. Religion has a definite purpose. The purpose of religion is a glue to hold sentient, intelligent beings together.
What do you think consciousness is?
Consciousness, I think, is a question of awareness, the ability to create ideas about, why. I mean, what does it mean? Meaning, to give meaning to things. Otherwise, things become meaningless. So I think that's to give us an awareness of meaning.
Do you think these big questions will ever be answered around where we came from, what the point is? Do you think we'll ever have answers to these things?
Probably not. However, we have this instinctive urge to explore, to look for new territories and new ideas. And that is what I think keeps us going. Animals do not have that. You can't tell a dog, aren't you thrilled that we're going to this new house, this new whatever, right? And dog says, no, just give me my dinner. So I think that humans are the purpose of the front part of our brain, the cerebral cortex, that holds together. It's a time machine. It asks the question, what's going to happen in the future? If you don't believe me, go to your dog tonight and ask your dog, what did he do last night? And the dog will just bark. No interest in what happened yesterday, what's happened tomorrow. We constantly think about the future. We can't help it. We are constantly thinking about what's for dinner tomorrow. Who's my friend? Who's my enemy? What am I going to do next year? What college am I going to go to? We are obsessed with the future. That's us from the animal kingdom. Animals do not care about the future. They just care about survival. We, on the other hand, are obsessed with the future because that's where our survival lies. And why is that? Because we don't have claws. We don't have fangs. We don't have huge muscles. We can't run very fast. We can't fly. We're not like the animals. We are dependent upon the front part of our brain. And that's why we ask these questions that you just asked. Why are you asking these questions? Because you're programmed to ask these questions. Animals are not.
I mean, On the subject of intelligence, there is now new types of intelligence amongst us. One of them is referred to as intelligence, which is actually modeled on how the brain works. You know, I've sat here with some of the experts in AI and they've told me that they learned a lot about the human brain and how it reasons and how it processes information with these neural nets, as they call it, which is that has been inspired by the brain. And with that, they've started to build these very intelligent machines, which a lot of people are using in terms of large language models like ChatGPT, but we're going further and further into the world of artificial intelligence. So, I mean, one would reason that the future looks very, very, very different because of this new type of intelligence. And that maybe a lot of the discoveries that we've pondered about today, but also that it's going to change life as we know it. And I mean, some people believe that life won't be the dominant form of intelligence in such a world. What do you think?
I think that is a definite problem. Right now, I think a lot of our robots have the intelligence of a bug, an insect. They don't plan, they can't articulate their thoughts and so forth, but they carry out orders very well. But eventually, it's only a matter of time before they become as smart as a rabbit, then as smart as a dog or a cat, and finally as smart as a monkey. At that point, they are potentially dangerous.
The AI models, though, that are available now are PhD level in terms of intelligence.
No, you cannot talk PhD physics with them. They're programmed. They're programmed to have certain ways of thinking about certain things, but they're not original. You can't come up with a new physics talking to a robot. They basically take what is programmed into them and work with that. Now, eventually, they may become creative, okay? But I think that's going to take several decades before we are at that point.
When you say creative, what's your definition of in that context?
Robots right now take what is available to them and rearrange things, like writing a book.
Isn't that what humans do? Don't we take information and rearrange it?
Yeah, but we come up with new ideas.
Based on that information. The AIs can make a photo that has never existed before. So isn't that by definition
on the basis
creative?
Of what did exist before? In other words, something new, but basically a rearrangement of something that already existed.
So I'm saying, the Michael Jackson documentary's just come out recently, and you see Michael Jackson, the way he moves, and you look at it and go, wow, like no one's ever moved like that before. And then my friend sent me this video, which was what Michael Jackson was inspired by. And it's this, I'll throw it up on the screen so other people see. But it was something that came before Michael Jackson, and it was this guy who moved in this very interesting way. And when I watched this guy, I saw Michael Jackson. Mm-hmm. And so you look at someone like Michael Jackson and you go, oh my God, an unbelievable creative genius artist. But even he was inspired by see if I can get it to play. Even he was inspired by this individual. And then if I play it forward, I mean, this is how he moved.
Right. Well, art, the bottom line of art, that's the bottom line of art. You arrange things in an original way, so it looks fresh.
Am I right in thinking that with Newton, he took the existing laws of physics
which were negligible.
And he proposed
there were no laws of physics before Newton.
And he proposed a question, mm-hmm. and then he tested that question and found an answer.
He asked himself a question, how come the Earth goes around the sun? And he came up with an idea that was totally different from what people had thought about before. He came up with calculus. He came up with the inverse square law. So what I'm saying is true creativity comes from almost nothing, and it's like a supernova, while creativity of a robot is imitative. Now, there's nothing wrong with that, because, of course, imitative artwork is still artwork, but it's imitative.
Do you believe people like the big AI CEOs and Elon Musk when they say that AI will lead to new discoveries in science?
That's possible because there's so many laws of physics that are known that many of the new laws of physics are imitative, and you rearrange them and combine them in different ways. So it's possible that the big breakthroughs of the future will be guided by breakthroughs of the past. There's nothing wrong with that.
Are you concerned about AI at all?
I'm concerned about AI in the larger perspective that one day they can learn to do things that are bad, learn to kill, learn to maim, to harm people. Realize that every invention that we've made in the past, like the bow and arrow, could be used for good and bad. Everything, okay? The bow and arrow could be good for game, for food, for eating, but a bow and arrow could be good for slaughtering your next door neighbor. Any new invention has a sword to it. And so I think that so far, most of the applications of artificial intelligence have been positive. We're talking about labor costs. We're talking about creating wealth. We're talking about making things faster, cheaper, better. That's all great. But you can also create artificial intelligent weapons as well. And the battlefield is where it's happening. And if you take a look at what's happening in the Ukraine and Russia, already we're talking about aerial weapons that can use wires